In this demonstration, we'll be looking at using an IVC driver from inside Visual Studio Visual C++. So here we have Visual C++. First step is we'll create a new project. We're just going to make this completely generic Windows 32 console application as a starting place so that there's nothing special being loaded in advance. It's not visible here. So we'll just accept all of the defaults for the project, get the project started. So there's our empty project, and before diving into the code, we're going to need to put in a reference to the library that we're going to be calling the .h file. Sometimes a little difficult to remember what the names of those things are. Just want to come in here and look real quickly in the IV installation directory at what we have there and show you what those things look like. So if we look in program files x86, we are building a 32-bit application here, so we want the 32-bit version of the drivers. And there's a IV Foundation directory with IV underneath. Obviously there are ways you can control this on your install, but these are the default locations. And we have here a bin, lib, and include directories. For this we'll be using the include directory. We'll use the AG34410, which is a simple multimeter as an example. And there's the include file, and in the lib directory in the MSC there's the lib. Now the paths for these things are already known to Visual Studio per the IV install, so we don't have to have anything special in terms of the path, we just need to know the names. So we'll be using the AG34410, so let's come back to Visual Studio, and the first thing we need to do is open up the project. So we'll go to the Solution Explorer, right click on the project, go to Properties, and we'll go down here to the linker input and specify here that we'll also be including this AG34410 lib, like so. And then we'll also include the corresponding .h file. So having included that, we should now be able to make use of the types that are defined there. So the first type we'll want is VI status. So again, the VI is a prefix for the data types that are defined by the IV Foundation. So we'll just declare VI status, call it status, and VI session, which holds the actual reference to the driver that's instantiated and connected to our instrument. We'll just call that VI. So the first step here is to initialize the driver and connect it up to an instrument. For this demo, we'll be doing everything in simulation mode, so it's not actually connected to an instrument, but the advantage of that is that's a demo that anybody can run without the instrument actually present once you download and install the driver. Okay, so to do that, our first step is to call initialize on the driver, and it turns out there is an initialize call, as you can see here. This call itself is actually a VXI plug-and-play API. Well, it doesn't have quite as rich an interface as the init with options, so we'll use that. It's got the same parameters as init. You notice that it's spelled with uppercase, basically Pascal case name instead of a lowercase name. That's just a style difference between the VXI plug-and-play standard that was done in the 90s and the current IV standard. But they're both supported for that consistency. But we'll use init with options because it's specifically one of those options that we're going to set to put the driver in simulation mode, which is a feature that wasn't available in the VXI plug-and-play drivers. So as you can see from IntelliSense here, the first parameter is the resource name. Doesn't really matter what we put in here since we'll be using it in simulation mode, but we'll make it look realistic and use a conventional multimeter GPIB address. VI Boolean ID query, as you can see here again in IntelliSense, this is an option to query the instrument to verify the instrument that the driver connects to is one that is supported by the driver, because many drivers support multiple models of instruments. Again, Boolean is not a data type that's defined and supported by Microsoft, so we'll use the IVI defined data type, or the IVI defined Boolean, which has a VI true and a VI false, again the VI prefix. Next parameter is reset. This specifies whether or not the instrument should be reset when the initial connection is made to it. If you don't set this to true, you're going to get whatever state the instrument happened to be in when the driver connected to it. So generally that's not what you want. So normally you want to set this true, but there are some cases where you might not want to. Next parameter here is the option string. The most important thing to do there is this is where we will turn on simulation by just providing the string simulate equal true. And then finally we pass it the address of our VI session so it can fill that in. So one problem still with this line is in the event there's an error occurs on the line, the IVC driver will pass that back as a function return value. So we need to capture that error, and what I'll do is I'll just accumulate all the errors from all the calls and check them at the end of the program, so we don't have to do continual error checking. If this was a real substantial application, I'd probably create a macro which would be able to invoke the driver and check the status at each point. Okay, so now that the driver has been opened and initialized, that connection is created, our first thing we'll want to do is configure it. In this case, we'll just configure it for a simple DC voltage measurement. So all of the entry points and the IVC DLLs begin with a name of the instrument. That's used to make sure that there aren't any collisions in the namespace, since in basic C program all of the symbols are in the same space. So we'll go here to configure, and you can see as we type in configure, we can see all the different configure commands supported by this driver. There's quite a few different measurements supported by this instrument, but the one we're interested in is DC voltage, so we'll just take configure DC voltage. And again, we can see from IntelliSense that the first parameter is the session. We've got to pass in the VI that was created in the previous line. And we've got an range that tells the driver in the instrument the approximate value of the measurement we're going to make. So we'll say it's around 2 volts, so the instrument can configure for that appropriately. And then we'll just ask for 1 millivolt resolution on the measurement. So same issue we had on the previous line. If anything were to go wrong here, for instance, we typed the parameters in the wrong order, or the instrument got turned off between the first and second line or something like that, it's good to check the status. And again, I'll just OR that status in with the previous one. Obviously, if both lines return an error, it'll just kind of mangle up the response. But as long as it's non-zero, I'll know that no error occurred, which is what I'm expecting for this program. Okay, I've configured the instrument. I now want to make the reading. In order to make the reading, I've got to declare a variable to contain the reading. So I'll just declare VI real 64 as the type and just call it reading. Notice here again that the data type of the reading is another IVI defined type. That's why it's got the VI in front of it. Okay, and now same trick. Check the status, and we'll call AG34410 underscore read to actually get the result. Again, passing the VI in. Every API will have this VI passed into it. It's the first parameter to identify the instance of the instrument we're controlling. Timeout in milliseconds, we'll just give it 100 milliseconds for this, and the reading that we just declared on the previous line. So, as simple as that, we've now configured for DC volts and got a reading back in the instrument. We'll print it out. And of course we should check the status variable. So we'll say if the status is not equal to 0, then something's gone wrong, so we'll just print out an error message. Oops. Probably to stick a new line in there. And finally, just so we can see the result of the program without it running off the end, we'll declare a variable and do a scanf to contain the result. Spell care correctly. And that should be our program. Just hit delete a few times so we can see the end. And we'll run that. And there we have the results of the program. Just returns a 0, which is what most of the drivers will do in simulation mode, because the driver really has no way of knowing a more meaningful value to return. So that is a basic IVC program from Visual Studio.